Hello everyone. Um, Today we are going to look at this question which keeps on popping up again and again as to why mobile networks stop working in case of some kind of emergencies like some disasters, earthquake, or some kind of a terrorist attack. Why do the mobile networks stop working? The main motivation were a couple of questions on Quora. If you don't know, it's a question and answer website, and I really encourage you to go and have a look. I really like the website. So the couple of questions were, one of them was why cell phones, as I noticed today, don't connect during or after mild earthquake tremor, and the other one is why don't phone calls connect after the earthquake even if there is no damage to network towers. So let's see. I'm going to try and explain what happens through a simple example. So let's consider a simple example of a bank. Actually, it could be any office, but I just decided to call it a bank. There is a security guard at the door, which allows anyone who wants to be serviced by any of these the people, any of the service desk. They have to go through the security guard, and for some reason I decided to put an exit as well, just to show that the security guy is just for entrance, so the people go away through another through an exit point which is different to the entry point. So let's say uh, the first person or one person comes to the security guy and says like, hey, I want to do some banking operation. So the security guy says, okay, yep, you go in. Another guy comes, the security guy says, okay, no worries. And then another one comes, yep, and another one comes. So they're all being served by different service desk, right? So users come to the security guy and he actually sends them to the service desk. Now what happens when two users come simultaneously to the security guy? The security guy says, oh, 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 stop. Like, you can't both ask something to me at the same time. I can't serve both of you. So you both back off for a random amount of time, right? And then whoever's time gets over first, you come to me. So the blue guy's time got over first and he came, and yep, he's now been sent to the service desk. And then the green guy's random time got over and he's been sent to the service desk as well now. Now what happens in case if there is some kind of a earthquake or some kind of a natural disaster? Suddenly a lot of people come to this the security guy, and the security guy can't handle all of them simultaneously. So he asks them like, hey guys, you know what? I can't serve all of you simultaneously. Back off for a random time. But the thing is, because of this earthquake or something, everybody wants to reach somebody else, and whether it's like a voice call or a data call, it could be anything. But the number of users just keep growing. So even though he might be asking everyone to back off for a random time, he's just not able to serve anyone, because it's like, it's like everybody just keeps on coming and saying like, oh, I want to be serviced, I want to be serviced. So it's like none of them are able to be serviced anymore. So this is the congestion problem, where nobody can get served due to the congestion. And congestion control should be used here to manage too many users trying to get access to voice or voice or data services from the mobile network. So to take care of this situation, congestion control, or which is sometimes referred to as load control, is used. And this is a mechanism to ensure that in case of congestion, priority users and emergency calls can still get served. So what happened in the initial release, like we're talking about LTE, the release 8 uh, introduced this concept of access class. So in your SIM card, each user is assigned an access class. So the normal users will be assigned an access class from 0 to 9, which is randomly assigned for like when the SIM cards are created, it's a 0 to 9 access class is randomly assigned. Then the remaining access class is used for like other people. So 11 for the PLMN use, or like the operator doing some kind of testing. The PLMN staff will have the access class of 15. Security services is 12, public utilities 13, and emergency services are 14. So what happened is there was a mechanism uh, by which what you can do is you can do access class barring. So in case of like a congestion, you can bar some of the users. So generally the normal users, the operator will say like, hey, access class 1, 2 and 3, or I don't know, maybe access class 4, 6 and 8, right, or some numbers they'll randomly bar, and that means there are less users able to now connect to the network, right? So the number of users, as we saw previously, they will be reduced because these users know they have been barred, so they can't connect to the mobile network. So they keep on increasing this number of access class which is barred till the congestion is under control. This is a nice little table from one of those NTT Docomo's technical journal, and this shows all the different mechanisms, uh, access class control mechanisms, the congestion control mechanisms that have been defined in standards to actually control this situation. And this particular video is not going to look at any of these in detail. So I discussed about the access class bearing, but then there is a service specific access control mechanism which was introduced in release 9, and then smart congestion mitigation in release 12, the extended access barring for in release 11. So, and these are all for different types of calls. So like extended access barring is only for MTC or machine type communication UEs, which is also like M2M UEs. And then the latest one is the access control for general data connectivity, ACDC, which is used only with certain applications. So there are a lot of different congestion control mechanisms which have been defined in 3GPP releases to manage congestion. Now let's look at another scenario. So, we looked at the congestion one, but in this scenario, the service desk, most of the service desks are nearly full, right? They are all serving some or the other user. So a new user comes and says like, hey, I want to be serviced by a service desk. So the security guy says, okay, let me check, and he checks. He says like, there are very few desks which are free, and I think I should keep some desks free for some kind of a emergency, like, or a high priority user or something like that. So he says, sorry, you know what, um, there are no service desks which can serve you right now, so you need to wait for some time till some more service desks become available. And this is what we call as the admission control. So here the users get served only if there are enough resources available. Now in some literature I have seen this to be being referred to as call admission control, or CAC procedure. So there are two type of admission control procedures. So the first one is the user admission procedure, and this is done when the user is trying to when the UE is trying to establish the RRC connection. So whether it's a RRC connection setup or the handover procedure, and this admission procedure looks at the CPU resources as well as the available radio resources and channel quality for this particular user, which can affect other users. The other one is the service admission procedure, and this is done when the RAB is being established. So the RRC connection is already been established, and then after that, when the RAB is being established or modified, this service admission procedure takes place. And this looks at the bearer type, whether it's a guaranteed bit rate or non-guaranteed bit rate, what's the priority, what's the QCI, the packet delay budget, etc., etc., to decide whether this user, this particular app can be set up or not. So this was in brief, just to explain the congestion control and the admission control procedure, and this shows why in a particular situation when there is some kind of a earthquake or some other disaster scenario, sometimes the mobile operator's network doesn't work. So I hope you actually found this very quick tutorial useful. As always, please leave any comments you may have in the comment section. Thank you.